All right, so hello everybody, welcome to my class. Um, so this is our second lesson of this unit, the introduction slash basic operations. We're going to go over some basic concepts in algebra. Last time we did order of operations. That went pretty well, all right. And today we're going to do some substitution, evaluation, that kind of stuff. So let's begin with our class schedule. Let me remind you that we will always have a class schedule, and you can see how the class is going to go. And usually I start with review, all right? I'm going to always start with review from last class. Well, obviously I'm not going to start with review with a new unit because we have nothing to review in that unit, but every other lesson in the unit I'll review the material from our last class. All right, so first we're going to go over some homework questions, and I'm not going to go over every homework question, okay? There are some easy ones that almost everybody got correct, but there are also some hard ones that I did see a lot of people miss, all right? A lot of people made errors and answers were all over the place. So then we'll be reviewing, of course, order of operations, but that'll be a short review. So then we'll go to evaluation, substitution, that kind of stuff. And then we're going to finally finish off with some practice problems. All right. Are there any questions about the schedule? If you have any questions about our schedule, yes, I am going to grade your homework. In fact, I've already graded all of your homework, all right? Let me, however, and I have added feedback on every one of your guys' homework. All right. So again, I'm gonna go over homework guidelines. All right. And this was the first bullet point here. You must show all of your work. This is what a lot of you guys missed. All right. This is what you guys missed a lot, right? Some of you didn't show your homework, so I had to give you a lot of zeros. All right. So you must show all of your work, or I won't grade your paper, all right? You must show your work. Okay, it's also in school, you have to show your work, right? So in here, you also have to show your work. And remember, I strongly recommend that you do your homework on a separate piece of paper, all right? What I would not recommend is that you do a digital version, all right? I do not recommend digital versions. I had a couple people send in the actual Google Docs. Do not do that. I want you to write out this homework because it helps you learn better than typing, all right? I want you to learn the symbols, that kind of stuff. So always, actually, don't even try to print the worksheet out because the worksheet, the space is actually very small. So what I want you to do is in your notebook, find some space to do your homework. Just copy the problems down. That way you can have a lot of space to do your work and it isn't very cramped. And well, if you have very small handwriting, I mean, it is okay to print the worksheet out and do it there. But if you know that you can't fit your handwriting onto that piece of paper, then don't. Just use a different separate piece of paper to do your homework, and that'll be fine. And most of you turn it in, all right? About like, how many of you? About like 12 or 13 of you, but I graded all of them. What I mean by turn in is that you have to select the turn in button on the Google Classroom, all right? So in the assignment, you can select the turn in button. I'm pretty sure you can do that. And then you attach a PDF or whatever onto there, and I can see it, the turned in ones, and I can grade them. For those who did not turn your assignment in, I could also see some attached files, so I went ahead and graded them as well. But always remember to turn it in first, all right? And very good job. Everybody completed their homework this time before this class, if not by the due date, all right? And again, it is due on the next Thursday after our class. And that Thursday is going to be January 20th. All right, this week. Oh, next week. All right, and back to what Isabella's question here. I did grade all of yours. All right. Why can't why can't you do it on docs? Well, because first of all, to do it on docs, you have to get the symbols right. And if you want to do it on docs, then you have to, insert equations, do all of that, and sometimes you have to do multiple lines of work. It's going to be very frustrating and very annoying, right? So I would recommend not doing it on docs. But well, if you show your work properly, I can let you do it on docs, but I just not recommend it. But anyways, showing your work is the key point of the slide, so make sure you do that. And back to Isabella's question, I did grade all of your work. It's out about 100, so there's 5 questions. Every question was like 20 points or so. So I did. Some people did get perfect, so congratulations to all of those who got perfects, 100s. But I did also put in some low scores in there, 20% or 40%. So make sure you must check your work again, right? So you must check your work. Make sure you're not making any stupid mistakes. All right. Okay. And I gotta say, well, the homework wasn't good or it wasn't bad. It was decent, all right, this first class, because their class average was about like 77%. So it was kind of decent, but not too good, not too bad either. So let's hope that this time the homework will be better. All right. So make sure you check your work and make sure you show all of your work. Okay, so I'm gonna go over quickly just some homework questions because I see that these are missed quite a lot. All right. This first one, what is this? Okay, this first one is the second problem from the homework, and I see some people got this incorrect, the -2 minus 2. So let me just go over this real quick. It isn't too hard. So, all right, so basically what you want to do is you need these parentheses, right? You need to do these parentheses first. And all right, and I think the problem was that a lot of people just didn't know how to just with the negative signs and all. So let me remind you that -7 here -5, that's going to be -12, right? Okay, that's going to be -12. So do not get confused on the negative signs. So -12 divided by -2 minus 2 minus -6. Now, I know there's a parenthesis here, but don't be fooled by this. Usually when we minus or subtract a negative number, there's going to be a parenthesis around, because that's how we write these negative numbers. So let me adjust the width of this pen first. Okay. Let's go back. All right. First, because don't pay attention to this parentheses first. You don't need to do -2 minus -6 first, because they're all like subtraction or addition, right? So we do it left to right. All right, left to right. Okay. Then basically it's just very easy from now. So it's going to be -2 minus 2. It's going to be -4 and minus -6. And if you have 2 of these negative signs here, you minus a -6. That's basically adding 6. So you can see that we have -2 divided by 2 here, which is -6. All right. So are there any questions on this particular question? I see that some people did miss this. All right. So are there any questions on how I solved that? So make sure you do check your work. All right. No questions. That's good. Okay. So next problem. This one, I'd like you guys to solve yourselves, or I'll give you a few moments to put your answers for this one, because I want to see again what those answers were, because I did see a lot of answers like all around for this one. And I did see like 200 something, 300 something, which is totally incorrect, but must have missed like the order of the operations somewhere. So I'll give you a few moments to put your answers for this one, okay? And then I'll go over the work and you can see which one is correct, okay? All right, so, and also put your answers like in the chat box, like we did last time, okay? And also, for those who have not checked your grades on the last homework yet, it's all on the Google Classroom, so you can see your work and the grade you got. And also about homework, just well, I ramble on, just do this problem first. But also about the homework, I added feedback for every one of them. And I also told you about which ones you got incorrect, right? I also told you which ones you got incorrect. So it is your duty to next time when you turn in today's homework that you need to make corrections, all right? Not only do we need to turn in the homework, we also need to make corrections, all right? So just have homework 1.2 in one page, all right? And then corrections 1.1 on another page. That's fine, okay? Or resubmit your old homework. All right, so is everybody done filling out their answers for this one? All right, yes, 16, that's very good. So how do we do this one? First of all, we have this outermost parentheses here, the brackets, the curly brackets. And then we take it a step further and we see these square brackets. Go even further, these normal parentheses. All right, so let's do those normal parentheses first. So it's going to be 2, all right, all of this junk. And then what's inside the parentheses is the exponent. So make sure you do the exponent first, but it's going to be 9 plus 1, which equals to 10, right? Multiplied by -1, right? Okay. So then we can see that our next step is these square brackets. So let's do these. But before we do that, we need to know that we need to do multiplication first and then do our subtraction, right? So let's write down this other junk. Okay, and we have 32 minus 40, which is going to be -8. Okay, then -1, right? But by this time, the square brackets have the same value of the normal parentheses because they're on the same level now. All right, so basically we're now going to do all of this multiplication, and actually, first we need to do the exponent, all right? The exponent, so let's just figure that out first, 64. And then we need to do all of this multiplication, right? So first we do -7 times -8. For those who don't know, when you take a negative number and you multiply by another negative number, it becomes positive, right? So it's basically 7 times 8, which is positive 56. But before you go any further, I saw that a lot of people combined the 64 and the 56. They got 120 multiplied by -1, got 120 times 2, -240. That's incorrect. Why? Because we need to do multiplication first, right? So if we do multiplication first, we get subtract 56. Then we get 2 times 8, and that is going to be 16, right? So our final answer is 16. Are there any questions on how I obtained this answer? Any questions? Yes, you need to correct your the questions that you got incorrect, all right? You need to correct them. That's how you learn, all right? You need to correct your mistakes, learn from them, you know. All right. So this next question, I'd like you to post your homework answers for this one. All right. So I'll give you a few moments to do that. Let's see what you guys got for this one. And of course, put it in the chat box. All right. So we have a couple people do that. Okay. 2. All right. We have a lot of 2s, and that is correct. All right. Congratulations to anybody that got that correct. So when we're working with fractions, and we're also having a little bit of absolute value here, right? So again, let's start with the top, right? We always start with the top. I mean, you can start with the bottom, but then you have to go back to the top again. But I'd rather go top to bottom. So let's do that. First, you know, exponents, and then we have to do this division here. So, okay. I think a lot of people that missed this didn't pay attention to this division over here. And that's why they got it incorrect. Okay. So this equals 5. Let's actually do this top part first. This top part. All right, this top. So let's not pay attention to the bottom right now. It's easier to subdivide. All right. So 5 plus 9 minus, then we get 24 divided by 6 equals 4 times 2. Again, do this multiplication first. It would be 5 plus 9 minus 8. Okay? Then what do we get? Just go from left to right. We get 14 minus 8, which is 6. Okay? And then for the bottom, and for the bottom, again, we need to do these brackets first. So, and then inside of these square brackets, we have parentheses. So let's do those first, 2. Okay. So 5 plus 3 times negative 1 plus, and then this absolute value. Now, with absolute value also is like parentheses. So anything inside absolute value wants to do that first, right? So again, in the absolute value, there's exponents 2 squared. So 4 minus 5 is negative 1. So let's reduce that to negative 1 first. Okay, and then in fact, if you take the absolute value of negative 1, which is, you know, the distance from 0, geometrically saying, and that would just be 1, right? So anything that has an absolute value is actually positive. So 1 squared is just equal to 1. Okay, now with these other brackets, okay, remember to do multiplication first. You get negative 3. 5 minus 3 is 2. So 2 plus 1 is equal to 3. Okay. And then don't forget, we need to divide these. And then after you divide these, that's going to be equal to 2. Okay. Are there any problems, any questions with this, any concerns? Okay. Any concerns, problems? Okay. No problems. All right. If you have no problems, then I will continue. Okay. But before I continue, I'd like to ask, are there any other homework questions that you want me to go over? Any other homework questions? Since actually the other homework questions are pretty easy, right? So hopefully, like, yeah, you guys don't need to go over them, right? If you don't need to go over them, so let me continue. Again, review of basic operations, then we'll go review definitions, and then we'll start on our new material. All right, this will be a fast review. So for our basic operations, we have addition, which you guys all know of, subtraction, multiplication, division, and then exponents a to the n, and then the nth root of a. All right, these two are new, but then again, we're mostly going to be using mostly a squared and mostly the square root of a. All right, so you don't have to worry about a to the 15th power right now, or the 15th root of a. We're just going to use mostly squares, square roots, okay? And a denotes any number, all right? Any number you want, okay? So let me review, our order of operations. So let me make this fancy. I just want to. All right, actually, that does not look like a P, so there we go. Kind of. Okay, so first we have our P, and then we have the E. Okay, and then it's going to be M and then N, and then D, right? M and then D, which is multiplication and division. But remember, there's that common misconception that multiplication comes before division. That's not true. They're on the same level. And when you have multiplication and division, you go left to right. Okay? And then what you have addition and subtraction. They're also on the same level, right? They're also on the same level, which means you have to go left to right for this one as well. Okay, so parentheses, exponents, multiplication, division, and of course these two are left to right. Okay, and then addition and subtraction, right? All right, all clear on our little order of operations chart over here. All clear on this, right? Everybody knows this? Okay. And I think that's about it for our review of order of operations. Okay. Yes, all clear. Okay, so next, let's go on with a review of basic definitions. All right. A symbol or a placeholder that represents a quantity or identity that may change. Okay. That is a variable. And first, I'd like you guys to participate and give me some examples of a variable from last time. All right. I want you guys to give me some examples of variables. All right. So what are some examples of variables? X. All right. Very good. We have X. Okay. You have X. What are some other examples of common variables you may see? A, X, Y, A, R, A, the alphabet. Yes, basically. So we have R. We see that quite often. N, especially when we're writing formulas for this one. N often denotes like an arbitrary number. All right. Okay. We can also have H, K. We use that a lot in analytic geometry when we're denoting points, right? Also, we have Y, don't forget that. And basically, A, B, C, X, Y, Z. We have a lot of basically the alphabet. You can use any number in the alphabet. You can have E, you can have T, B, A, anything. Okay? And a lot of these, some of them, well, you don't see E a lot, right? E, that's something called the natural base. We use that in natural logarithms, but don't have to worry about that right now. But most of the letters in the alphabet can be used as variables. All right, so just don't be freaked out if you see a lot of numbers or letters because they're just variables. All right. Okay. So an expression is a valid combination of mathematical identities with at least two terms in one mathematical operation. So you can give me some examples expression, right? 5 times 4 plus a is equal to 25. Okay. Now this one is actually not an expression. Why? Because it has an equal sign. Remember that expressions do not have equal signs, right? So you can't have an equal sign, okay? But we have expressions like 4 times 5 times 6 plus 7 plus 8, that kind of stuff, like 4 times 4, all right? These are all expressions, all right, mathematical expressions. Now, can anybody give me an example of an algebraic expression? Any algebraic expressions here? Okay, give me some examples of algebraic expressions to show that you know what they are. All right. Algebraic expressions basically are the same thing, but with variables. Exactly. X plus 1. X plus 1. So let me use the example. And so what? X plus y. Yes, we have x plus y. So let me use 3x plus 1 as my example here. Remember that our numbers here. Okay, so we have all of these terms. Let me do this curly bracket again. Okay, these are our terms. Okay, this is called the constant. All right, this is called the constant. Again, this is called the coefficient. But this is with just one single variable thing, or like just this is a first degree polynomial, but with just very short expression, this would just be called a coefficient. But if you have something like 4x to the fourth plus 3x squared plus 2, this would be called the leading coefficient, all right? Leading coefficient. Basically, if you have a lot of these exponents and you go down all the way, a lot of terms, right? You have more than like two terms, then this would be called leading coefficient, all right? But you don't need to worry about that now because you won't be going into polynomials until like about the end of this semester, okay? So this is the coefficient. Of course, this would be the variable, okay? So that's about it for an expression. So now let's go on with some equations, all right? So an equation is a mathematical statement consisting of two expressions of the same value set to equal each other. All right. This is the key point here. All right. Equal sign. Expressions do not have equal signs, right? Expressions do not have equal signs, but equations do have equal signs, and we can do really amazing things with that equal sign because we know that they're equal to each other. And that's basically the main point of this today's lesson because it's substitution, right? Because they're two values you can use interchangeably, right? Okay, so some examples of equations. Who can give me some examples of equations? I did see some equations earlier because there were some equal signs, right? So some like equations. Who can give me equations? Yes. 4 plus 4 equals to 8. That's correct. 6 plus x is equal to 14. 9 plus 0 is equal to 4 plus 5. A lot of them, right? A lot of them. Okay, so I'm going to take Hugo's example here. 3x plus 1 is equal to 8. Very good. See, there's an equal sign here, okay? And when we get to linear equations, we need to find x because of this equal sign. All right, so we can have all sorts of examples here, all right? So now let's move on to our new topic for today, substitution. All right, so what is substitution? Substitution is basically plugging in a number value for the variable in an algebraic statement. And that's not always the case for substitution. There's a lot of appliances in substitution in mathematics and geometry. It's different, but in algebra, well, the most common definition would be plugging in a number value, right? We're mostly going to be working with number values, but in geometry, you're going to be working with congruency, that kind of stuff. You're going to be plugging in like all kinds of like supplements, complements, that kind of thing. So mostly in algebra, we're going to be plugging in number values or whole expressions for the algebraic statement. So examples of substitution, okay? Some examples of substitution, okay, we can have, let's say, 3 is equal to 4 plus, no. What am I thinking? 4 minus 1. Okay, let's do that instead. Just ignore what I just did. Okay, that's dumb. Anyways, actually, I'm going to use that 5 somewhere else. Let's say 5 plus 3 is equal to 8, right? So then what we need to do is, let me just experiment with the substitution, right? Let's experiment with this equality sign, right? So since 3 is equal to 4 minus 1, then they can be used interchangeably, right? If they can be used interchangeably, then basically 4 minus 1 can be substituted in for 3, right? So 5 plus 4 minus 1 should also be equal to 8, keeping the equality, right? And that is true. It's basically 9 minus 1, which does equal to 8, right? It does equal to 8. Okay. So that is just one example of substitution. And also, in the next few examples, we're going to have like x equals to 3, then you're going to plug 3 in for x, right? We could also have y is equal to x plus 1, and we can have z plus y is equal to 10. Okay, then you can plug x plus 1 in for y, right? So z plus x plus 1 is equal to 10, right? So that's how you use substitution. When we're solving systems of equations, we'll use a lot of substitution. But you'll also use substitution here and there, right? We're going to be using it a lot. So if you didn't know how to do it, well, now you learned. Okay, so let me go on to our example 1, and then we're going to do some practice problems, all right? About 5 of them, yeah. All right, so our first one here is example 1. Basically, we're going to evaluate this, okay? And I also had some evaluation problems, right, in the homework. And so this is how you do it, right? We have s in here in this expression right here, and you have s is equal to -2. All right, so I made it so you guys can unmute yourselves and chat. So, right, yeah, you can unmute yourselves. Okay, so can anybody tell me if you want to evaluate this? Well, obviously we can't evaluate this right now, right? Because we have this variable. We don't know what s is. Well, actually we do. We know that it's -2. So how are we going to evaluate this? What's our first step? Okay, what's the first step?
We plug in.
Substitute s with -2. That's correct. Very good. Substitute -2. And I also see that William is raising his hand. All right. Is that what you also wanted to say? To substitute s with -2? Yeah. That's
Yeah.
correct. Okay, very good. So basically, if you substitute s for -2, since they're both equal, you can use them interchangeably. It's going to be -10 plus 7 is equal to -3. Okay, so that is how we evaluate this. Okay, are there any questions on how I evaluated this? And of course, our practice problems are not going to be this easy, right? This is a very easy example, right? And of course, in the homework and the practice problems, I'm not going to teach you everything, all right? I also want you guys to figure it out, all right? The examples I'm going to give are much easier than the practice problems, okay? I want you guys to do a lot of it yourself, all right? So that's how you grow, how you learn. I can't just give you everything, okay? So you want to find out for yourself. Right. So no questions. So let's move on with our next one. And there's not a lot of notes here today. All right. There's not actually a lot of notes here today because we just reviewed about a lot of time, and we're just main concepts are substitution and evaluation. Yeah. Okay. So determine the validity of the statement. Okay. Ooh, big word, validity. Well, not really. It's not big. Statement is bigger than it. But in case you don't know what validity means, it basically means verify if this is true or not. So say true or not true. And we're going to take this big equation here, scary looking equation, and let's see if it is true. If x is equal to 0. So what is our first step here? It's very similar, almost the same. It actually is the same as the last problem, all right? We substitute in 0, all right? So does anybody know, is this true or not? Do we know if this is true? All right, William says this is true. All right, are there any other opinions? Kaylee says it is false. Isabella says it is true. Hugo also thinks that it is true. Okay, you have a lot of truths and one false. Okay, and so how do we figure this out? We substitute in 0, right? So basically, we're going to have substitute in 0 for all the x's, all right? So we're basically going to have 2 times 0 to the 5th times 0 minus 2 squared times 0 plus 8. Now, since now it's all like numbers, right? So it's not that scary anymore. Okay, so next step, how are we going to do this? Well, automatically we know that it's equal to 0. Why? Because, hold on, let me erase this. Okay, why do we know that's 0? Look at this exponent. 0 to the 5th is going to be 0. And we know that anything times 0 is going to be 0. So here, it's going to be true, all right? It's going to be true. Anything multiplied by 0 is going to be 0. So it's always true, no matter if this was x, no matter if this was x minus 100. I don't care, because it's multiplied by 0, right? Anything multiplied by 0 is going to be 0. So when you see one of these scary looking equations, you can have 4x to the 4 times a lot of factors, you know. If you have just this separate x right here, and you know x is 0, then everything it multiplied by is going to be 0, then this would always be true, right? So make sure you pay close attention to little details like that and avoid showing like large amounts of work when you just have to show very little work, right? It's not like I don't want you to show work. It's just that you need to be very efficient with your work, all right? And for these, in the homework, I also added one of these problems. So when you're determining the validity of the statement, make sure you also show your work. And in the case that you get to something like this, it's not true. So what you need to do is, you know, put a slash through it and say false. All right, so that would be your answer. Okay, this would be the final answer, but do show all of your work before that. Okay, in case it isn't true, then put an unequal sign right, to it. Okay. So I see there's some chat comments. So, okay, it's true, right? Is there confusion over this? Oh, typo. Okay. Right. But if you do have any confusion over this question, then do ask questions. Okay. So now let's go on with some practice problems. We're going to have 5 in total, and we're going to practice some of the concepts of substitution, you know. All right, so I'll give you a few moments to do this problem. make sure you write your practice problems in your notebook, and make sure you were taking notes during this class so you don't forget these concepts, and you can always have your notebook to look back to, all right? You can always have it to look back to. All right. All right. Let's check our answers. Seems like most of you have answered this. Okay, we have a lot of fours. And yeah, this was a pretty easy problem. Shouldn't have gave you that much time, probably. Okay, so yeah, this is pretty easy, right? So basically, first step, sub in -4. -4 plus 2 squared. Now, again, order of operations, do the parentheses first. So -4 plus 2 is basically just -2 squared. Okay, this is equal to 4. Okay, very easy. Now, this one is a little bit harder. Okay, so I'll give you some time to do this. Okay, so let's check our answers here. We have a lot of negative 18s and one negative 15 and 168. Okay, 168. That's a bit out of the ordinary, but okay. We also have another 168. Oh, never mind. Okay, so let's see which one is correct. Actually, I haven't really done this myself either, so let's see. So we have our v equals to 1/4. Okay, so what is our first step? We need to substitute it in for v, right? Substitute it in for v. So our expression would be 12 times 1/4, actually 1/4, yeah. 1/4 times 32 times 1/4 squared minus 8. All right, so we have a lot of parentheses. We see that this outermost parenthesis. Let's do that first. Okay. So inside that, we have 32 times 1/4 squared. There's an exponent here, so let's do that first. What is 1/4 squared? Let me make a note here. When you have a fraction a over b and you square it, you're going to get a squared over b squared. And also when you have a fraction here and you square root it, you're going to have the square root of a over the square root of b. So make sure you pay attention to that, all right? So just a quick note here. And again, we're just going over the basics here. So we're going to learn more on this when we get to our exponent section, but it is good to make a note of this again first. So when we get 1/4 squared, it's basically 1/4 times 1/4. That's going to be 1 squared over 16, okay? 1/16. So 32 times 1/16 minus 8. Okay, and I have noticed that we are running out of time again, so we might go over time today again. So sorry about that. But then again, we still have a couple. We have like 3 more practice problems, so it shouldn't take too long. Okay. So then again, we have this parentheses. 32 times 1/16. Make sure you do multiplication first. Okay. So you have this. And then 32 times 1/16. That's basically dividing by 16. So that's 2 minus 8, which is -6. And then now it's just all multiplication. So make sure you do left to right. Okay. So 12 times 1/4 is going to be 3. This is basically dividing by 4. Then you multiply it by -6. It's going to be -18. All right. It's going to be -18. So congratulations to those who got -18. I don't know how you got 168, but yeah. Actually, how did you get 168? Kind of how struggling to okay. So I don't know how you got 168, but certainly out of the ordinary. Okay. Make sure it's probably like order of operations mistake, right? So make sure you do pay attention to the order of operations. Okay. So our next problem here, we have multiple variables this time. So it's multivariable. X cubed minus 3y if x equal to 1 and y equals 4/3. So let's do that.
Can you go back to the last question? I still need to like write it down.
Oh, okay. I'll go back. And please tell me when you're done so we can move on to the next problem.
Okay.
And it is also good for everybody else to make sure you take note of this little note here. And if you did not
I'm
know
done.
that,
I'm done.
okay, you're done. Very good. So next problem here, evaluate x cubed minus 3y. All right, I'll give you a few moments to do this. And I'll check back to see your answers. All right, let's see your answers. We have 9 answers. Very good. So I see most of you guys answered -3. Very good. All right, it wasn't that hard this time. Okay. So basically, we just subbed in for each respectable variable, okay? Respectively, whatever. How do you say? Okay, now we got you. Okay, let's ignore that. All right, x cubed at x equal to 1. So basically 1 cubed minus 3 times y is going to be 3 times 4 over 3. Okay, and if you did not know, 3 times 4 over 3, well, you're both dividing by 3 and you're both multiplying by 3. So basically these cancel out. All right, these cancel out. So then you're going to be left with 1 minus 4 is equal to -3. Hold on, let me rewrite this negative sign to -3. Okay. Any questions on this one? This was a pretty short one, so I assume you don't have much questions. Okay, no questions. Very good. All right, so our fourth question here is going to be which of the following satisfies 5n squared plus 3n minus 1 is equal to 1? All right, we have some choices here. Okay, and actually, I'm going to not give you that much time for this one because we are running out of time. So, sorry if you don't have enough time to do this problem, but we're just going to have to move a bit faster for this one, okay? So I'll give you just about like 1 minute or so to do this. And then we should be able to finish in time. All right. Let's see our answers. We have 10 answers. Very good. We have B. All right. A lot of B's. Okay. Bn equal to -1. All right. Very good. We all have B's. Very good. And so there's a very fast way you can do this problem. First of all, look over all of your answer choices and then look at this equation right here. All right. Pay attention to big exponents. Whenever you're doing these kind of problems, pay attention to big exponents because big exponents, once you have like even 2 squared is going to be 4. 1 squared is going to be 1, right? There's a a 3 digit, no, not digit, just a very how am I supposed to explain this? Well, there's a bigger gap in between 1 and 4 than 2 and 1, okay? Because it rises exponentially, right? So especially these big answer choices, you can just eliminate them, right? Eliminate it. Because -2 squared, it's going to be 4. Then multiplied by 5, right? That's a big number. It's going to be 20. And then you're going to add 3 times -2, which is basically subtracting -6, it's going to be 14, right? And then you subtract a measly 1. How's that going to be equal to 1? Obviously, it's not going to be equal to 1. And of course, if -2 won't work, then obviously 2 won't work. Because, again, this is also going to be 20, then you're instead of subtracting 6, you're going to be adding 6. Then you're going to have 26. And again, you're going to be subtracting a measly 1. That's, of course, not going to be equal to 1. So we're left with a couple choices here. We have B and C. Let's look at C first, all right? If you have n equal to 0, now if you have the 0 as the answer, that's actually pretty easy to eliminate or see if it's correct. Because once something comes in contact with a 0, it's most likely going to be a 0, right? So n squared, 0 squared is going to be 0, multiplied by 5 is going to be 0, then 3n is also going to be 0 because they're all multiplied by 0, right? Anything in here multiplied by n or 0 is going to be 0. So you're going to be left with -1 is equal to 1, which is obviously not the correct answer, so you're going to be left with B. Then you can see if you plug it in, 5 times -1 squared, actually, -3 minus 1 is equal to 1, and we get 5 minus 3 minus 1 is the 1, and that is correct. All right, very good. That is correct answer, B, and a lot of people got B, if not almost all of them, yes. Almost all of you answered, and all of you that answered got it correct. Very good. Okay, so now we have our last problem here. Determine the validity of the statement 10 over 4 minus p minus 2 is equal to -7. Since we did run out of time, I'm going to just walk you through quickly over this one. Again, you need to substitute first. Okay, so 4 minus p is going to be 4 minus 8. All right, so 10 over 4 minus 8 minus 2 is equal to -7. Is this true or not? So let's see. It would be 10 over -4. Okay, and if we want to simplify, okay, let's simplify actually. So it's going to be 5, -5 over 2 minus 2 is equal to -7. Now we don't even need to finish solving this because obviously it's not going to be equal, right? It's not going to be equal, so the answer is false. All right, so that is going to be our answer. False.
Can I see the previous slide?
Previous slide. Okay, previous slide. All right, and of course, let me make a note here actually. A and D eliminated. because the exponent too big. All right, so make sure when you're looking at these, you can eliminate them, but I want you to show your work for each part of the questions. All right, especially I have a multiple answer, multiple choice question in the homework. So let's say you decide to eliminate A and D. So at A, you don't need to show any work, right? Because you can say eliminated, and so, and say the reason. Okay, so you can say that, right? And I can see your thought process here and how I want to, if you get it wrong, how I need to correct you. Okay, and see your thought process here. So how you eliminated the problems. Okay, so A and D were eliminated because the exponent is too big, right? C eliminated. There's a zero, right? Too many zeros. Okay, only -1 left, right? See, if you have a zero, then anything that comes in contact, which basically means divides or multiplied by 0, gone. It's going to be 0, right? And you're left with -1, which does not equal to 1. Okay, so then obviously B is the correct answer. So make sure you get that down as well. Make sure you eliminate things. Okay, then you can do it very efficiently. Okay, and that was our last practice problem. All right, so thank you for listening, everyone. Okay, thank you for listening, and I'll see you next class. All right, goodbye, everybody.
Bye. Thank
Yeah.
you.
Goodbye. Thank you for listening.
Bye.
Thank
Bye. Thank you.
Yep. Thank you.